T results. We can use T results for a couple of things. So there's the 3 T results there. It's really important every time you do your T result, the angle on the left, like the tan theta, on the right, it'll be tan theta on 2. The angle on the right's always half of what it is. Whenever you're using T results, you have to define what the T is, and it's always half of what's out the front, okay? Now, if we look at this question here, it is one of the examples in the book. Prove that cot theta on 2 minus cot theta equals tan theta on 2. You don't need to change the cot theta on 2 or the tan theta on 2. You would just write the T result for the cot theta. Now, remember cot is 1 on 10. So let's start with our left-hand side. So we're going to write cot theta basically in terms of theta on 2. So when you're using the T results, you're always writing it as a half angle of what you've got there. All right, so the left-hand side is cot theta on 2 minus 2 cot theta. Now, why don't I write this as 1 over tan theta on 2 minus 2 over tan theta. Are you okay with that? The 2 is not on the denominator. So there's our T results. Hand side equals tan theta on 2. You know tan theta on 2 is just going to be T. So we're hoping that when we fix this all up, we get T. All right, so we've got 1 over, what's tan theta on 2? Isn't that just T? Minus 2 over, what's the result for tan theta? 2t over 1 minus t squared. So over 2t over 1 minus t squared. Now, instead of doing that, so it's 1 over t minus, because it's 2 divided by that, it'll be 2 times the bottom one divided by the 2t. So, are you okay? You know, instead of doing that, why don't I just write 1 minus t squared over 2t? Would you be better with that? If you want, I don't have to write it as 2 over tan theta. I can write 2 cot theta, and when I write the tan theta result, I write it upside down. Do you get what I'm saying? So instead of writing that like that, because that's quite messy, right? No, you can leave it if you want. Or, all right, I'll leave it. I'll leave it. Over 2t over 1 minus t squared. Instead of writing it like that, next time we're not going to write it like that. We're just going to go 2, because it's the reciprocal of tan, so I'll just write it upside down. 2 bracket 1 minus t squared over 2t. But if you want to show how that equals this, if I've got 2 divided by 2t over 1 minus t squared, isn't that 2 times 1 minus t squared over 2t? Can you see that it's 2 bracket 1 minus t squared over 2t? So if it's 2 divided by that, or if it's 2 over tan theta, or if it's 2 cot theta as it was, you just write the tan theta result flipped next to it. All right? Now, what should I do you think? You know, I can go common denominator, or can't I just cancel out the 2's on this? So I've got 1, so my denominator is a t, minus 1 minus t squared all over t, because the 2 denominators are the same. Or I could have gone common denominator and put 2 over 2t, but no need, because the 2's cancel on that second fraction. And now what do I get? 1 minus 1 plus t squared on t. Well, that's just t squared on t, which is t, which equals, that's t, which is tan theta on 2. Now, so when you see a combination of theta on 2's, leave them. Just change the theta one. Do you get that? Question from Cambridge, exercise 2b, question 5e. Prove that tan theta times tan theta on 2 divided by tan theta minus tan theta on 2 is sine theta. All right. T results, obviously. What does sine theta equal in the t results? 2t over 1 plus t squared. In other words, when you manipulate this left-hand side, you're hoping to get 2t over 1 plus t squared, and when you do, we can write that equals sine theta. That's what we're aiming for. Now, notice we have a combination of tan theta on 2's. This is t equals tan theta on 2 already. I don't have to do anything with the tan theta on 2's. They are t already. That tan theta on 2 is t. That is the definition of all the t formulas. Sine theta is 2t over 1 plus t squared, where t equals tan theta on 2. Cos theta is 1 minus t squared over 1 plus t squared, where t equals tan theta on 2. So when you see the tan theta on 2, you should be happy. That's just t. So let's start with our left-hand side. It's tan theta times tan theta on 2 over tan theta minus tan theta on 2. In other words, we just have to write the expressions for tan theta. And what is the expression for tan theta? Isn't it 2t over 1 minus t squared? Where t is tan theta on 2. So I just changed the tan thetas. So I've got 2t over 1 minus t squared times, now I don't need to write tan theta on 2, why don't I just write times t, because tan theta on 2 is t, divided by tan theta is 2t over 1 minus t squared minus t. And I'm going to write where t equals tan theta on 2. So this is all my stuff on the side. So we've got that. We need to get rid of these 1 minus t squared denominators. This is 2t times t. So that denominator is 2t squared. So when I multiply that numerator by 1 minus t squared, I lose the denominator of 1 minus t squared. Over, when I multiply this by 1 minus t squared, the denominator goes, I just get 2t. And when I multiply the t by 1 minus t squared, I just multiply it by 1 minus t squared. All good? I'm multiplying, that is one term. It's tan theta times tan theta on 2. That is 2t over 1 minus t squared times 2t. Sorry, I've missed. Yeah. So that numerator there is 2t squared. Are you okay with that? That's it there. Because I've now multiplied by 1 minus t squared. I might move that times t a bit closer so you don't miss it. Okay. So what do we just expand? 2t squared over 2t minus t plus t cubed. What do you think we should do? Take out the t, bracket 2t over, oh, isn't this just, sorry, isn't that 2t squared over t plus t cubed? Because 2t minus t is t. So it's t bracket 2t over t bracket, what? 1 plus t squared. That looks familiar. Which is 2t over 1 plus t squared, which is the result for sine theta, which equals sine theta where t equals tan theta on 2. At tan of 7 pi on 8 equals 1 minus root 2. Remember, we're just in prelim course. Pi is 180 degrees. In other words, the question is, show that, we're just really saying, show that tan of 157.5 degrees equals 1 minus root 2 using t formula. That's what the question's asking you. Okay? Okay. Now, if it's using t formula, either that amount's got to be doubled or it's got to be halved. I don't think, and when you double it or halve it, you're going to come up with an exact value. Now, if you do tan of half of 157.5 is something and a quarter, that is not an exact value result. So let's try doubling tan of 157.5. What's double 157.5? The t formula for tan we'll use. We know that tan theta equals 2t, or 2 tan theta on 2, over 1 minus tan squared theta on 2. Now that's the t formula for tan. You've got to decide, is this 157.5 degrees going to be your theta on 2, or is it going to be your theta? Well, it should be your theta on 2, because when you double 157.5, you get 315 degrees. And we know the exact value for tan of 315 degrees. So we're going to let the theta on 2 be 157.5 degrees. So this is what we've got. So that means that theta is 157.5 times 2, which is 315 degrees. So we're going to use this T formula. Theta on 2 is going to be my 157.5. And we know it has to be because if you look at 1 minus root 2, that is the solution of a quadratic equation with a surd. So it has to be where the squared one is and the ordinary tan is. That's your 157.5 degree term. All right. So I've got tan of 315 degrees equals 2 tan 157.5 degrees over 1 minus tan squared 157.5 degrees. We okay? Because I know, and I'm just going to do it over here, that tan of 315 is quadrant 4. It equals negative tan 45, which is negative 1. It's quadrant 4. So now I can just write tan 315 is negative 1. So negative 1 equals 2 tan 157.5 degrees over 1 minus tan squared 157.5 degrees. Now, instead of using tan 157.5, can we just write T? All right. So I'm just going to write that negative 1 equals 2T over 1 minus T squared because it's just getting too messy. All right. Where T is tan 157.5 degrees. You know what to do now? Solve. So cross multiplying negative 1 times 1 minus t squared equals 2t. Expanding negative 1 plus t squared is 2t. Taking everything over to the left, you've got t squared minus 2t plus minus 1 is 0. But you can't solve that. You could have if it was plus 1, but you can't. It's not a perfect square. But, you know, looking at the question gives you the hint that you are going to use the quadratic formula. Because, you know, when you use a quadratic formula, you get 1 plus root 2, 1 minus root 2. That's what we're going to get. 1 plus root 2, 1 minus root 2, more than likely. One of the solutions is for our quadrant, and the other solution is for a different quadrant. Okay, so let's solve. So t is negative b, which is 2. Plus or minus the square root of negative 2 squared is 4, minus 4 times 1 times negative 1 over 2 times 1. So you can just, I like to write my b squared straight up. All right, it's negative 2 squared, which is positive 4. But I like to do that all written out. That's where a lot of people make the mistake, is this bit. So it's 2 plus or minus, is this plus? Root 8 over 2. Which we know is 2 root 2. 2 plus or minus 2 root 2 on 2, which is dividing everything by 2, 1 plus or minus root 2. Now, we're doing tan of 315. Sorry, no we're not. We're doing tan, so isn't T tan, of 157.5 degrees? T is tan of 157.5 degrees equals either 1 plus root 2 or 1 minus root 2. Now, tan of 157.5 degrees, which quadrant? This is in quadrant 2, so it's negative. So therefore, it's equal to 1 minus root 2. So I'll just... this is definitely positive. That's not my answer. This is negative. Okay? So this one's negative. So therefore, the tan of 157.5 degrees is 1 minus root 2. And you need to explain why. In quadrant 2, tan of theta is negative. Or theta on 2, whatever you want to call it. I'll just write tan is negative. So it's got to be the negative one of those results. Tan through 315 equals negative 1, and we put that there. We do get two solutions down here. The other solution is for negative tan 45.